Good morning, everyone. This is Carl Griffith. I'm the Director of Emerging Technologies at Graybar, and I'd like to thank you very much for joining our G2 Talk webinar series today. Before we get started, I'd like to pass on a little bit of information to you about Graybar and what we are all about. Our mission or our vision at Graybar is to help our customers power, network, and secure their facilities with speed, intelligence, and efficiency. And today, we meet that mission by talking about healthcare and our discussion about healthcare and lighting that touches all of these, power in terms of networking and security. We have an initiative at Graybar that we call Power Smart, where we focus on the retrofit and renovation of existing facilities. And again, we're hitting that Power Smart button by talking about healthcare as the facility today. If we think about Power Smart and we talk about the power piece, meaning about helping our customers save energy, we hit that with lighting. But on the smart side, we also talk about technology in our buildings or our facilities or healthcare institutions. Hitting that smart button there also has to do with lighting. So lighting is both power and lighting is both smart. If you're on the webinar with us today, I wanted to let you know that the first 50 people that come online and stay with us during this webinar will receive an email from Graybar, and you'll get a coupon for a cup of coffee that you can exchange for a cup of coffee at a local, at a national coffee chain. And so we encourage you to do that if you're one of the first 50 people. At the bottom of the screen, you'll see a little Q&A box button down there. If you hit that, a dialog box will open, and it will allow you to type in a question. At the end of our webinar today, we'll have an opportunity for Q&A. If you'll type your questions in there, we'll address as many of them as we can. I wanted to let you know that this presentation and other G2 Talk webinars are all archived on graybar.com. All you need to do is just hit the G2 Talk webinar logo on Graybar's homepage. It'll take you to the archive, and you can download this presentation and the accompanying white paper that goes along with it, or you can view any of the other G2 Talk webinars that happen to be archived up there. Our subject matter expert today is Karen Gale. And Karen is the Vice President of Healthcare of the Healthcare Vertical for Acuity Brands. I've met Karen several times. I've been in some of her training classes, and she's been up here at Graybar's corporate office talking to us about lighting in the healthcare vertical. She has a tremendous amount of information about lighting, particularly in the healthcare space. She has 14 years of lighting experience in the lighting industry. She holds an MBA and a BA from Georgia State University, and it's just my pleasure to welcome a great person. You'll really enjoy this. I want to welcome Karen Gale to our G2 Talk webinar series today.
Thank you so much, Carl, and thank you, Graybar, for having me in this webinar. Good morning to everybody. I think it's morning, most places. It is my pleasure to spend a little bit of time with you talking about lighting and healthcare. Those of you that know me know that I could probably talk a day and a half at a minimum about this topic. We'll try to do the elevator speech and condense it in a short amount of time. And really talking about lighting and healthcare and smart lighting upgrades. And what's really interesting, I talk about smart lighting upgrades, and a lot of times we go straight to energy. We go straight to efficiency. And it's not like that's not important. Certainly we're going to talk about energy. We're going to talk about efficiency. But what I really think when we look at the devices that we have today, when we talk about smart, intelligent systems, what we're really asking ourselves to do is to think deeper. What more can it enable? So yes, I can deliver to a healthcare facility a more efficient system, but what else can I unlock? Can I unlock an improved patient experience? Can I unlock better productivity, better performance from the caregivers and staff? And in so doing that, can I do that with less? Can I use less energy? Can I have a lower maintenance burden? Can I have a lower footprint? So what we're trying to set the expectation about when we look at lighting upgrades for existing facilities is let's try to have it all. And let's think holistically as we look at these spaces so that we can deliver more value to our clients and to our customers. So that's really the premise. one of the things that's really interesting, I don't know if Carl made me sound old or experienced, but, in the 14 years that I've been in the lighting industry, so much has changed, and most of that change has happened in the last, I would say, 5 to 7 years. We have completely transformed the way that we look at light sources, many of the old constraints that we would typically think about with legacy light sources, incandescent bulbs, linear fluorescent lamps, they're gone now. And so, not to mention the control side. And I'll talk about technology later, but what I find really fascinating, as much change that has happened on the lighting side, the healthcare environment is probably one of those industries and sectors that has changed the most dramatically. What's changed in healthcare in the United States in the last 5 years? Well, other than the basic tasks about delivering care, everything has changed about their fiscal models, reimbursement models. So what I really believe is if we can kind of look at what the industry is going through, what are some of those key trends, we can develop better solutions because we know where the pain is. So we're going to start the conversation there in really what is changing with the healthcare environment. This next slide is kind of interesting. We all know that the cost of healthcare in the United States it's incredibly high. And what I find is interesting is that those costs are expected to double in 10 years. This slide, if you look all the way to the right, you see where the United States is, where healthcare as a percentage of GDP is about 18%. It's nearing 18%. Every other company that precedes us on this slide has a lower cost of care with respect to per capita spending. This is one of those applications where it's not great to be first, right? It's not great to be the highest one here. We know that something has to change in terms of delivering care because we're not even best in the world in terms of outcomes. So how do we spend less of our GDP on care while improving outcomes? And that's the major challenge. This situation here was really the catalyst for some of the policy changes that we see now, specifically Patient Protection and Affordable Care Act. The implications for us from a lighting perspective is what's changing in reimbursements and how can we tap into that. So costs are high, we know that. And a typical hospital margin is between 4 and 5%, according to AHA, American Hospital Association numbers. So we know that costs are high, facilities have constrained budgets, and so there's not a ton of room to move, so we really have to be smart when we think about adding more value to these clients. With respect to policy changes in the recent past, I just want to talk, I'm not going to spend a ton of time on this, but I really want to spend some time on a few key points that are really instructive for us when we think about how do we have it all in a healthcare facility and what lighting can enable. So there's a real push from volume on the healthcare side to value. So if I think about a typical inpatient environment in the old days, which, funnily enough may have been, as short as, 5 years ago. In the old days, if I had an inpatient facility, it was great if my census was high and I had my beds full. In the new world, I really want to move care to the lowest cost model. That's really what I'm trying to drive. So a lot of my outpatient and ambulatory facilities are really going to get more demand as more people become insured. And so my inpatient facilities will be higher acuity, sicker patients. Okay, so there is this shift from volume, so more procedures, to value. What is the quality of care? What is the perception of the environment of care? And the perception of the environment of care is really what this slide speaks to. Ever since about 2006, although measurements, incentives, and reimbursements really came into play in about 2012, Medicare and Medicaid services, so CMS, created a survey which is really a patient perception survey. Now bear with me, it's the most awkward acronym you'll hear today, but it's HCAHPS, and it stands for Hospital Consumer Assessment of Healthcare Providers and Systems. And it's basically a patient perception survey. So it acknowledges that us as healthcare consumers, maybe we don't know how to critique the brain surgeon that just did surgery on us. We don't have the vocabulary. I don't know who's out there in the webinar universe. I certainly didn't get the med school training to critique this brain surgeon. However, I can form an opinion about the environment of care. So was the staff attentive? Were the nurses friendly? Did the place look clean? Was it quiet? And we know that sometimes perception of care and perception of service is as meaningful as the actual quality of, say, clinical process measures. And what's really important about HCAHPS and what the dramatic change is, patient perception matters. It drives a certain portion of reimbursement. So you remember I said that most hospitals have an average operating margin of between 4 to 5%. What's happening with HCAHPS is the survey is mandatory for acute care hospitals, and if your HCAHPS scores don't improve relative to your peers as a hospital or over time, what's at stake is about 2% of your revenues that you may miss out in incentive payments. So that is really, really significant, and that's something that we're really taking notice on. When you look at other changes in reimbursement, we know for some time that if I had a hospital-acquired infection, so it came in for one procedure, got a secondary infection, hospitals wouldn't be reimbursed for that. We're also seeing tightening up on reimbursements for things like excess readmissions. So what you see here, the big takeaways on reimbursement is experience and perception. That's becoming a bigger portion of the reimbursement package, and people are paying more attention to it, as well as we need to maintain our focus on safety, infection control, and quality of care. If we move forward, and this is sort of a deep dive into HCAHPS a little bit, and we'll bring this back up later, when I look at all the different things that patients could say about their environment of care, so how is the communication with nurses? How is the communication with doctors? What about pain management? I look at the high bars here, but if you look at what the lowest bar is in terms of what this slide says is which of these, what's the average HCAHPS score? So these are dimensions where hospitals are asked questions. They ask their patients questions. So the quietness of the environment, for example. Where you look at that bar that's the next to last one, where quietness of the environment has a 61 there, basically what that is saying is 61% of the patients surveyed said their environment was always quiet. So always is the top box score. And so the big takeaway from this slide is that's our biggest pain point when we're looking at patient perception, noise. Doesn't mean that we don't work on everything else, but noise is the biggest HCAHPS deficiency. And this is last year's numbers. We'll bring that up later. It'll be relevant. Can lighting impact noise? The other thing that we can talk about as well is energy. We're always going to focus on energy because we know that in a healthcare facility, they're very energy intensive, the most energy intensive building other than fast food. But when you look at the consumption due to the 24/7 nature or extended hours, lighting as a percentage of your electricity, so not just energy, your electricity, is about 40 to 42% of that electricity. So we know that it's energy intensive. Lighting comprises a large portion of the electricity bill. So again, this is an area that we can focus. So we really do have it all to do when we are thinking about healthcare requirements. We have to deliver right light levels. We have to make sure it's easy to maintain. We have to pay attention to aesthetics, infection control, integrate daylight, comply with codes, meet budgets. Where do we start? So a couple of things that I want to talk through with respect to trends before we get into specific applications is what's happening here. And first I'll talk about this one big trend that we see in the lighting industry quite a lot is this link between light and health. We are learning more about the health impacts of lighting, and we've really got a good body of research to build from. So we always know that lighting helps us see. Okay, lighting is probably the biggest thing that helps us see. This is sort of one of those Captain Obvious statements. We know that. And we have photoreceptors in our visual system, rods and cones, that really drove most of that visual function. So rods for nighttime primarily, cones for daytime, to simplify it. What we found in 2001, 2002 is a third photoreceptor. And so just like the ear really supports our hearing but also balance functions, what we found is that lighting supports visual function, but it also helps keep us entrained on a roughly 24-hour cycle. So we found, awkward acronym alert, we found another photoreceptor. They're called intrinsically photosensitive retinal ganglion cells, IPRGCs, that really impact our circadian system. And our circadian system is what you would call kind of a biological clock, right? So roughly 24 hours, and then regulating things like sleep-wake cycles, other biological functions. So it is most sensitive to blue light, and we'll talk about that. This is just a visual of the mechanism. Our internal biological clocks aren't exactly 24 hours. Depending on the person, you might be a little bit less than that. You might be, 24 and a half, 25 hours intrinsically. When we get light, whether it is natural light or higher intensity electric light, what it does is it keeps us entrained with a 24-hour day. And typically what you would do to regulate circadian rhythms is that you would have higher intensity light in the early morning, particularly in that bluish region of the visible spectrum, okay? And then you would have lower intensity and more reddish amber light in late afternoon and evening if you're mimicking the outdoors. What happens is when we are sleeping at night, right about an hour and a half before we go to bed, our body starts producing melatonin. Melatonin, we're day-active mammals. It tells us, hey, you're sleepy, it's time to go to bed. If we were nocturnal animals, it would tell us it's go time. And so in humans, what you really want is melatonin to be produced when it is time for you to sleep, because melatonin has really protective benefits on us. So it helps reduce tumor growth, those types of things. Melatonin is only produced at night for humans. So once we finish sleeping and we wake up and we get that higher intensity blue-rich light, that tells us to be active, and it doesn't interfere with our sort of sleep-wake melatonin production processes, just as a background. What we're finding is, and the key point with this slide is, we're getting really close to being able to look at systems where not only do you drive the visual benefit, but also you can provide more circadian stimulus, not just through the inclusion of daylight, but also through electric light. So we'll talk a little bit more about that at the end. So this next slide is really interesting. You remember I talked about circadian rhythms and one of the processes that it really helped drive and, or help regulate, which is the sleep-wake cycle. So, it used to be you would look at the news and you'd hear talk about the deficit and you'd think it was a fiscal thing. And now when you look at the news and you hear them talk about the deficit, it's our collective sleep deficit. I joke that this is one thing that all of us want and nobody's getting any. Sleep. Sleep is the big epidemic of the 21st century if you start looking at mass media and public health trends. And I won't necessarily go over all of these in detail, but I want to bring us back to the spaces that we're talking about. We're talking about healthcare. So when you think about applications like inpatient, or you think about long-term care, think about assisted living, skilled nursing facilities. Sleep is an inherently restorative thing. If we don't sleep, a lot of bad things happen. This slide is the bad things that happen. And so when we think about hospitals, and let's tie some ideas together. Okay, many people think that hospitals are really noisy, not really a great place to sleep. Sometimes when we are in these facilities, think long-term care, think inpatient, we don't get enough light to really help regulate our circadian cycles. As a result, we actually are creating environments that are sicker, not necessarily conducive to wellness. So when we tie some of these ideas together, we think, boy, in healthcare we have an opportunity to do more beyond visual acuity. So lots of bad things can happen if we don't get enough sleep, and this is something that we pay attention to when we're thinking about how do we do more for healthcare facilities. Aging population is a big one. When we look at the baby boomers, the oldest baby boomers turned 65 in 2011. So if you look at the pie chart, we've got this long life expectancy. When you look at the pie chart, 2010, adults 65 and up comprise 13% of the population. As you go in the next 15 years, it's going to be about 20% of the population. So what that means is that we're going to have to focus more on lighting for older adults because, 20% of the population can't be ignored. This is the single biggest demographic driver that is driving an increase in demand for health facilities and new construction. We know that older adults are the, power users, if you will, of the healthcare system. So this demographic trend is something that all of our facilities are noticing and are trying to gear up for as a result. So patients 65 and up make up half of hospital visits. We know that. They're also visiting outpatient facilities more. As you get into long-term care, you certainly are looking at an older average age, closer to 80 for long-term care, particularly in skilled nursing. The big takeaway here is not just a demographic discussion, but we see differently as we age. Even though, I'm in denial about it, we see differently as we age. So as we look at what's happening with demographics, how are we lighting these facilities? Are we delivering enough light? Are we delivering glare-free light? The changes with the eye that occur with aging are just, this slide is just here to give you a good rule of thumb of what to do as you're considering lighting upgrades. So a good rule of thumb is older adults need 3 to 4 times more light than younger adults. And the reason for that is kind of demonstrated on this slide. Less light is just actually transmitted to the retina. So if you're 25, I love those days, 25 was a fun age to be, 100% of the light that's transmitted to the retina gets through. When you're 75, it's only a quarter of that. So we do need more light. We also need to manage the glare. The reason for that reduced light transmission is our pupils get smaller and they don't adapt to dark and light as quickly, and our lenses get darker. And we also have an increased prevalence of eye diseases. So if you're looking to relight a space and in the healthcare environment and you think less light is the answer, it's probably not based on what's happening with demographics. How do we deliver light smarter? That's really the key. This last kind of trend slide really then talks about what's happening on the nurses' side. So this is basically an age distribution of registered nurses, and it puts it in 5-year buckets or cohorts. And what you see, the line to pay attention to is sort of the light blue line with the dark blue squares. And that's really showing you the age distribution 2008-2010 of registered nurses. And so that the tallest spike there is 51 to 55 as an age bucket. So everything that I said about the patient side and people getting older and needing more light, let's think about our nurses as well. We have nurses whose eyesight maybe isn't what it was 10 years ago, 20 years ago. So for things like clinical processes, exams, those kind of things, we definitely don't want to skimp on light levels. So when we look at intelligent lighting systems, so moving from trends into lighting systems, this next slide is just basically saying, look, we want our systems to stop being so lazy and do more to enable the task. So, I have a light, I have a luminaire, and it's glass and gas, and it doesn't do anything. I've got bulbs, I've got metal, it turns on and off. That doesn't fly in the new world. We want our lighting systems to do more, not unlike we want our phones to do more, or tablets, which didn't even exist. The pace of change is more rapid, and we're all getting more demanding. So when we talk about intelligent lighting systems, we really think about this in terms of what is the kit of parts that you need to be able to deliver that greater value in a space. So when we think about smart lighting systems, I think you've got an image of LED luminaires and lamps. You could also include OLED if you'd like. Digital controls, daylight. So as much as possible, we want to use our resources around us so we can do more with less. There are also really great benefits with daylight, which I'll talk about. And then software. Everything's an app. This idea of the hardware being the star of the show, that's already changing in the lighting industry. And we expect it to light up, but what can it do for us once it's in this space? And having systems and interfaces and software that allow us to do more, that's really the trend, and that's really where it's going. So in terms of solid-state lighting sources, many of you on this call have heard ad infinitum the benefits of LED. Maybe some of you have not seen OLED, but solid-state lighting does have a lot of very obvious benefits that we're really trying to tap into. Not just energy, but longevity, the ability to control it. So many of our incumbent sources, our older sources, controls weren't an option. Think about outdoors. How did the dimming of your HID parking garage go? It probably didn't. You probably could not do that. Some of it was just completely infeasible. So we can use less energy. It lasts longer. We can dim it. It starts up instantly. All of these benefits are well documented. And what's really exciting about solid-state lighting sources is we have more standards and guidelines to help you differentiate what's a good system, what's not such a great system. So if you layer on that you're going to use an inherently smarter, more efficacious source, then what about controls? In the old days, I remember that you could be working with a client on a system and you'd hear, well, nope, the client doesn't want controls, or controls are too complicated. We just want the fixture. The crazy thing is you sometimes hear that now, right? You hear that now with the LED systems. But the truth is, with newer solid-state systems, the controls are really along for the ride. So really to unlock the potential, controls are kind of your gateway. So what this slide shows you is if you look at the top half in blue, this is talking about life of the luminaire. And if you look at the green, at the bottom portion in green, it talks about energy savings. And the takeaway is the more of these strategies that you layer on, you can get benefits both in the life of a solid-state lighting source, but also in terms of energy consumption. So that helps you on the maintenance side for life. It also helps you on the energy side. So things like digital lumen management. I'll talk about an application later that sort of describes that. This is one where we say, okay, if I want this light level in this space to give me 30-foot candles on a nurse's desk, or 100-foot candles in exam mode, essentially what I'm going to do is, instead of overlighting this space like I did in the past and then letting that light source depreciate, I'm going to program it that way out of the gate. I'm going to underdrive it at first, and as the source degrades a little bit or depreciates a little bit, I'm going to gradually, slowly drive it at a higher current so that I can just get that same constant light put from day one to day who knows when. And so digital lumen management is really that idea. But the great thing about it, I call this very much, this is low-hanging fruit. You can easily save 10% while pretty much doing nothing at all. Essentially all you said is, I just want the same light level throughout the life of this source. So that's a great one. That's low-hanging fruit. We'll talk about bi-level switching, manual dimming, occupancy sensing, which may not be appropriate for every single application in a healthcare setting, daylight harvesting, and then the idea is when you combine some of these strategies, you can get up to 68% energy savings in this particular example, which was an indoor example. If you move forward, the benefits of daylighting are very well documented in terms of energy reduction, but also satisfaction, productivity, shorter length of stay for healthcare, reduced pain medication. So as much as possible, we want to include daylighting in our healthcare spaces. The last thing that we talked about, I already talked about it a little bit, was usable software. So whether we're talking about indoor controls, outdoor controls, how do the users in this space configure their system to allow the lights to do what they want, whether it's dim down at a certain time of day, whether you want to see how much energy you're consuming. The software is really what's unlocking the potential there. So in terms of specific strategies, and there are so many different approaches to take that I wasn't overly prescriptive, but what I really want to do in this section is just kind of talk about, if you were thinking about a smart lighting upgrade, here are some great targets to start with. You may have already considered these targets and be on to the next space. If so, that's fantastic. Keep going. But a lot of these initial spaces can subsidize the rest of your renovation strategy. So a lot of different paths to take, but let me just talk about three for a second as you start off on your journey. So we're trying to get benefits in operating and maintenance costs while improving patient and staff experience, as we talked about earlier. the winner's circle, right? So you see gold, silver, bronze. I'm not going to tell you which is gold, which is silver, which is bronze. It depends on your project. It depends on the opportunity. But parking lots are such a huge one. I mean, starting from the outside is just really a fantastic way to go about it for healthcare facilities and many others. With healthcare facilities, you've got a couple things. You've got this idea of a need for safety and security. In some cases, it's heightened because you've got 24/7 activity, depending on where your hospital is located. Safety and security is even more important, I would argue, in healthcare than many other commercial spaces or institutional spaces. The other thing is just legacy outdoor lighting sources were just really inefficient. So you had a couple choices. You may have had metal halide, which gave you better white light, but was still not that efficient, not that long of a life. Or you had high-pressure sodium, which everybody loves that nice yellowish light. So you couldn't tell if a car was brown or red, but yes, it lit up the space. If power went out, it took you a while before that light came back on, but that's what we had. Now with solid-state lighting, you just have so many opportunities, both quality of light, directionality of light, but also how do you control it? So if you look at this example, and just a really quick example of a parking lot, and in the before picture, what you were using was 250-watt metal halide in these area luminaire fixtures, which with that and the ballast gave you 300 watts in per area luminaire. So 300 watts per area light there. So what you see in the top left going to the bottom right is that this particular parking lot was then renovated to an LED source. Okay, so you went from this metal halide source to LED, and you saved some energy as a result. In fact, you save over half the energy. What you can see in this image, it's really tough to see, I think, is that, it's an old adage that people park near the parking poles because it's brighter, it feels safer. But with older technology, there's only so much you can do with physics, right? So you had this point source, this large bulb, and so even through all the optical acrobatics, we try to bend light, we try to shape it, you would always have hot spots, and then it would drop off to these dark areas. What we find with LED is that because you're dealing with these smaller point sources, you can distribute the light more evenly. So the fact that you have more uniformity in the space in terms of your maximum light output versus your minimum, so max to min in an application, your perception of the space is that it feels brighter. So the more uniform the space, the greater the perception that it feels brighter. So that was just simple going from one source to another source, you get 50% savings. This next image basically shows that, okay, what can you do with dimming? So for example, at 9 o'clock at night, 10 o'clock at night, you may want 100% output. But what happens at 3 a.m.? Do you need 100% output? So this shot attempts to show that, okay, you had 144 input watts when you just changed the sources. When you dimmed it to 45% at, say, 3 a.m., you got to 80% savings. So that's how you can layer on and get, dramatic kind of unprecedented savings levels through that. Another application that in some ways, if you've got a parking structure that you're looking at, might be even better, is a parking garage. So here's an image of a parking garage. And what's kind of great about parking garages when you're looking to, again, improve the experience, right? So safe, secure, okay, so people know where they're going. People feel safe when they are there. They can navigate very safely from their car to the facility. But because of the high operating hours, so 24/7, right, parking garages, you're always going to have lights on, you can get even more energy and maintenance savings from this application. So this particular slide, which is a by the numbers slide, really kind of talks about why this is a great application. If you haven't relit every parking garage on your campus or in your region or state, go forth and relight parking garages. They're perfect. You've got inefficient technology that had a very low lamp life. You've got these long burn hours. The installation, you usually have several fixtures, hundreds potentially, and in many cases there are utility incentives that support this. So this next slide really just shows an example of LED savings versus 175-watt metal halide. And with the 175-watt metal halide in that space, which did give you a nice white light but didn't have the dimming, was really kind of inefficient, you went from 210 watts, input watts per fixture, to 74 watts per fixture. And this is not even with dimming, okay? So with the metal halide source, you were only looking at 10,000 hours rated life, which means that, half of them could, that's not very long, versus LED source where you're looking at 100,000 hours plus. And so if you are conservative and you look at 10 sets per kilowatt hour, which it may be lower in your market or higher in your market, what you're doing is looking at dramatic savings. So 64% in this case, you saved $120 per luminaire when you took into account operating and maintenance. So parking garages, and there are a number of different examples of this where you can we've done projects where you can get even more aggressive savings, but that's another great application. The third one, before I close, is really this idea of, if you remember the HCAP slide and the fact that noise, quiet environments, the noise was sort of the biggest complaint. We find that looking at corridors and common areas, both for source replacement but also having an adaptive strategy where you are dimming the lights down at off-peak hours or quiet times, plus incorporating lumen maintenance, can give you just dramatic sources, even when you're replacing a pretty efficient source like linear fluorescence. So having tailored distributions, lumen maintenance, bi-level dimming, things like that can really give you great savings, and there's so many examples to talk about there. So obviously I could go on like the entire day talking about this, but to really sum it up, I do believe you can have it all. I think energy and maintenance, we have to target that. We have to provide our healthcare clients some relief there because it's not an easy environment. But in so doing, we can also support the fundamental work that they're doing every day in these healthcare facilities, which is providing care, providing a better patient experience, and allowing their staff and their caregivers to be more productive on the job, which is what we all want. So with that, I thank you so much for your time, and want to kick it back over to the facilitators for closing and questions.
Thank you, Karen, very much. That was an outstanding presentation, and we really do appreciate your passion for lighting in the healthcare space. I wanted to remind everybody that there is a time now for questions, and Karen is at our disposal here to help us answer our questions. All you have to do is hit the little button at the bottom of your screen. It says Q&A. A dialog box will open. You can type your question in there, and then we'll restate it to Karen so she can answer it for the entire group. While we're waiting for folks to answer their questions, Karen, I do have a couple questions I'd like to ask you. In the beginning of your presentation, when we talked about these circadian rhythms and the effect that it has on patient health, et cetera, when can we expect to see these type of systems or lighting systems that take into account the circadian rhythm? When do we begin to start seeing those appear on the market?
It's a great question. That third photoreceptor that I talked about, Carl, is a relatively new, we just put a name to it probably in 2001. And so if you look at the body of work in the last 20 years, there's been a lot of research really trying to understand the mechanisms and how light impacts our circadian rhythms. I'll say this. We are at the point, I think, in the industry where we're moving, the research will continue, but we're moving into applications now. And I think, not having a crystal ball, that you'll see more systems focused on circadian support in the next, year and a half, 2 years. The reason I say that is because we're starting to get pretty clear on what we know and what we don't know. So in terms of what we know, we have a lot more information on lighting for older populations in facilities, so things like skilled nursing facilities. We kind of know their activity, we know their light exposure, and so experiments and studies done in those spaces have had good results in terms of, Alzheimer's and those kind of things. Lighting and circadian light has helped relieve a lot of the symptoms of Alzheimer's, dementia, those kinds of things. So I would see that products in long-term care would be more forthcoming. Maybe you'd also see it in inpatient. The area that research is continuing and we still need more research is what you do for shift workers. So we know that blue light at certain times will suppress melatonin and make people feel more alert. So could we do that at night? The problem with doing that at night is suppressing melatonin is not a great thing for our bodies because melatonin protects us health-wise, so tumor growth, those types of things. So there's some great research that shows that red light can be very alerting for nighttime shift workers. So what I'd like to do is see more of that research come out so that we could come up with a prescription for, rotating shift nurses as well as, people that sort of follow the external day. So hopefully that answers the question.
So Terry asked this question, and it follows on exactly with what you're talking about, is there any talk or is Acuity working on the development of, and Terry asked this, two-color LED light sources like cool and warm, light sources that have different color temperatures, or if we even went one step further and take a look at what we can do to have a multi-range of color where I can go completely from blue and I can go all the way to red and the entire spectrum in between. When do we expect to see light sources that will provide us that capability that can do exactly as you described? And as Terry's looking for, maybe the first step is just cool and warm.
Mm-hmm. Yeah, I think obviously that lighting is essential. And the ability to support circadian rhythms or just give people a sense of the passage of time or give people some visual interest and positive distraction, we can do that through light. So one of your questions, I'll start with the last one where you talk about saturated color or even just changing hues, so colored light in the space. There are a number of different, Acuity has a number of systems on the market now that would allow you to change the hue of the space or to help support mood. So we know that in areas, in a lot of healthcare areas, children's hospitals being a perfect example, using colored light in the space can help people feel less anxious. In terms of color temperature, and I didn't spend a ton of time on lighting basics, but going from sort of a warmer color, cooler color temperature to a warmer color temperature, those products are starting to emerge. Tunable light systems, they may not drive circadian stimulus, but we see them being used in this space to help give people that are confined indoors. We spend 90% of our time indoors. That changing white light color over the course of a day can help people get a sense of passage of time, which psychologically is very supportive for us. I think you'll see a lot of those systems. Some of them are already on the market in addition to things like dim to warm. Those are emerging. You're going to have a lot of choices on that front. The circadian side is probably the side that will be the slowest because it's really trying to drive a physiological impact as opposed to just kind of a visual one, if that makes sense. So, RGB, RGBW, so color systems, those are available. Kind of tunable white, warm to cool. Acuity has some products that we've done on projects, and you'll see a greater portfolio coming out. And then Circadian is probably coming as well.
Jordan asks a question about OLED. At a high level, can you briefly describe what is OLED?
Absolutely. And so my background is I'm not a scientist, so I'm gonna give it to you in my terms, so nobody cringe. OLEDs are like, so if LEDs are kind of these semiconductor-based kind of crystalline point sources, right? So forward voltage, it lights up. What OLEDs are, and I can maybe go back to the slide that have an image of it, is that they are these flat, planar, diffuse sources. So think about it as a lighting, like a peanut butter sandwich. Okay, it's organic because it's carbon-based. Okay, so it's not necessarily because it's good for you. OLED stands for organic light emitting diode. And so basically, so in this image here, you've got a substrate, which may be stainless steel. It may be something like a glass or a plastic to make it completely transparent. You put carbon-based molecules on the top. You encapsulate it with mother glass. You put forward voltage through that. It lights up. So this is, in the lighting business, we've always had diffuse sources, and we've always had point sources. So where I need punch, I use a point source. Where I need an overall ambient diffuse, I use an area diffuse source. And so that's really what OLED gives you. OLEDs, I would say, we're probably 3 to 4 years behind the inorganic LEDs. but we're really starting to see them catch up. Acuity has a pretty broad and growing range of OLED products that are making it out to the market. The biggest thing on OLED in the past were things like, okay, well, the lifetime isn't as good as LED, or wow, it costs a lot. What you're going to find with some of these next generation sources that you're seeing on the market is the lifetimes are exceeding many of your traditional filament-based sources, and the price points are coming down as well. So it's becoming less of a luxury and something that is getting more mainstream. It is still going to be a little bit more upmarket than the LED at this point in time, but it's so exciting as a source.
When we talk about sensors in lighting control systems, we know that we have ambient light sensors that can talk to us or tell us a little bit about, what's the outside light contribution into a space, and we have occupancy sensors that tell us about, whether the patient room or doctor's office is occupied or not. But when we think about this in terms of the Internet of Things and big data and collecting data that can help us make management decisions inside our hospital, in terms of controls and specifically with sensors, what's the direction of the industry here? And specifically, personally, my own question is about asset management. One of the things that happens in hospitals is we lose wheelchairs and we lose IV pumps in hospitals, and we don't know where they are when we need them. Another thing is even more important is protecting assets like human assets like the patient or the baby or the baby's mother to make sure that they're all where they're supposed to be and whether they've moved around in the facility. Is it possible that we can integrate lighting controls and the sensor systems with these asset management systems? And is Acuity working on solutions to help the healthcare industry with this?
Well, from an Acuity perspective, and hard to speak on behalf of the industry, Acuity's always cooking up something exciting. We've got, engineers and scientists locked in rooms doing all kind of fun stuff. But to answer your question, Carl, and I think it's a great one, that's why lighting is really exciting now. Everything that we talked about in terms of these applications, it means that you are working now increasingly with 100% digital systems. Okay, and these digital systems can be connected to not just other fixtures via wires or probably more. You'll see it more in the future wirelessly, but they can also connect to building systems. They can also communicate to other devices in the space. And so what I think is really exciting is the potential of that. So, if an hour doesn't go where I don't hear about the Internet of Things, but the potential of lights talking to each other, lights talking to devices within the room, things like wearable technology, your Fitbit or whatever it is, that potential certainly exists. I think the big thing, when I talk to healthcare end users and when I talk to designers in this space, the technology, I'm not going to go out on a limb and say there are no technological hurdles to clear. There's always work that needs to happen from a technology perspective. But I firmly believe that technology is not the constraint with some of these application ideas that you mentioned or these needs that we have in this space. Asset management, wayfinding, we see it in retail, how light fixtures can get people to GPS positioning to go to a rack and find their shampoo. Technology is not the constraint. We're going to have hurdles in the healthcare side because of how sensitive and interaction with other medical equipment, but those are challenges we can figure out. So I think I just put it out there and say, listen, let's all collaborate to design the lighting systems of the future because it can do more than it ever could before.
All right. Karen, we're about out of time here, and for those that have entered a question and we haven't answered it, we're going to address all of those questions offline, so you'll get an email from us and we'll answer those questions directly. Karen's presentation in PDF format will be available on the archive, so if you would like to go back and review the slides, you can go up to the graybar.com G2 Talk webinar logo and go to the archive and you can collect that. There's also a white paper up there about lighting solutions that you can download, I think. And we just thank you very much for the time that you gave us today. 50 of you that were online with us this morning will get a coupon in your email for a cup of coffee, and we're glad to give that cup of coffee to you today. You can exchange it at a coffee store near you. If anybody online would like to have a further discussion about lighting, maybe a lighting assessment in your particular facility or whatever, if you'll just give us a shout out to your local Graybar organization or contact us here at the G2 Talk headquarters, so to speak, we'd be more than happy to direct that inquiry out into the territory and begin a conversation with you about lighting and lighting controls in the healthcare space. Karen, again, thank you very much for your time. We appreciate it. Everybody have a wonderful day. Thank you.